Okay, this is our Algebra 2, Unit 4, Lesson 8, and this is a review lesson, and it's going to be over all the different ways that we have learned so far to solve quadratic equations, and we have used quite a different methods so far. And then up into this lesson, we're going to learn about what the discriminant is, and this thing, the discriminant, just a really simple formula. It can help us identify which of the methods that we've already learned is the best, the most efficient method to use based off the equation we're being given. Okay, but let's start off with reviewing all the different types of methods that we have learned so far for solving quadratic equations. Now, up here at the top, we have the equation x squared plus 6x plus 5 equals 0. And we are going to solve this equation right here that I've highlighted in red. We're going to solve it 5 different ways, okay, because that's how many methods that we have learned so far. So if you remember, the very first method that we learned when doing quadratics was by graphing. Unit 3, we spent a lot of time on graphing quadratic equations. If you have a graphing calculator at home, it's very simple to do. But to graph this equation, we are going to need to plot points on the coordinate system. So we need to make a table of values. If you're not using a graphing calculator, and again, I know a lot of you are having to do distance learning at home this week, and so hopefully you're really watching this. Remember, there was a formula that you could use to find the vertex, because we always start by finding the vertex, which is located like on the middle of the table because it's in the middle of our graph. And there's a formula to find the x value of the vertex, which is x is equal to negative b over 2a. Well, let's go up here and label. A is a number in front of x squared, so it's 1. There is no number there. B is the number in front of x, so that is positive 6. And c is the constant. It is 5. So when we do negative b over 2a, we have negative 6 over 2 times 1. So we have negative 6 divided by positive 2, which equals negative 3. Again, that is the x value of the vertex. So I'll put it right there. Then to find the y value for that vertex, we are going to plug it in for the x's in that equation again that I've highlighted in red. So we have in parentheses, we always use parentheses when we plug numbers in for variables. So I have in parentheses negative 3 squared plus 6 times negative 3 plus 5. And I hit equals on my calculator, and it tells me that this is equal to negative 4. So our vertex is negative 3, negative 4. So, my graph is kind of tiny here. I'm going to say, 1, 2, 3, 1, 2, 3, 4. Miss Larson's eyes are getting old. About right there. And then remember, we work to the left and to the right of the x value of the vertex. So we would say to the left of negative 3 would be negative 4, negative 5, and negative 6. To the right would be negative 2, negative 1, and 0. And then remembering that all parabolas are symmetrical, we really only have to plug in half these values. So we could plug in negative 2 or negative 4, doesn't matter, they're going to give us the same answer. Negative 2 squared plus 6 times negative 2 plus 5, and that is going to equal negative 3. And because negative 2 is negative 3, I know that there's symmetry on either side of the vertex, so they're both negative 3. And then we could plug in negative 1, so we have negative 1 squared plus 6 times negative 1 plus 5, and that's going to equal 0. And if we plug in negative 1 and get 0, we will get 0 when we plug in negative 5, again, because of symmetry. And then we could plug in 0, so we would have 0 squared plus 6 times 0 plus 5, and that gives us 5. Okay, plotting all these points now. Okay, on either side of that, we're going to negative 3, and then we are at 0. And then we're at 1, 2, 3, 4, 5. Sorry, I'm talking quiet. I'm using my thinking voice. Hopefully I got the right spot. Woo! We'll go back. All right. So remember, solutions are where the parabola cross the x-axis. So we're crossing the x-axis here and here. And what are those x values? Those x values are -5 and -1. Now, if you couldn't see it very clearly because this graph is kind of tiny, it is also at these values right here that I'm circling. When the y value is 0, that's where we're crossing the x-axis. So you can see it here on the table as well, where our two y values were 0, x was -1 and -5. Now, that was very, it worked. We had to graph the whole thing. We had to plug all those values in and then plot the points to get the picture of the graph and then to find the solutions by where the graph crosses the x-axis. And that works. It doesn't always work very effectively, though, if we weren't dealing with integers, numbers that are not fractions or decimals. But it did work in this case. Now, because we are solving the same equation over and over again, we already know that the solutions will be -5 and -1. That won't change. We're just going to show how we can get that same solution of -5, -1 using different methods. So the next method that we're going to use is factoring. So I'm going to move this up a little bit. Okay, so again, what is that equation that we are using? I'm going to write it down again. We have x squared plus 6x plus 5 equals 0. Now for factoring, we do need to be set equal to 0. So notice we are set equal to 0 already. And then for factoring, when we factor, the words factor mean the parts that multiply to make the original. So how can I turn x squared plus 6x plus 5 back into a multiplication problem? Well, remember, a lot of times it's about how many terms are in the problem. So I'm counting 1, 2, 3. That's factor tree. We're multiplying to the last number 5, and the two numbers we're looking for have to add to 6. Now, again, we do know the solution here, but we are in luck because the only two numbers that multiply to 5 are 5 and 1. And +5, +1 multiply to +5, and 5 plus 1 also equals 6. So we found those two numbers. So then we write this equation in factored form, which would be x plus 5 in parentheses, and then x plus 1 in parentheses, and it's still equal to 0. Now at this point, we're wanting to know where these factors would cross the x-axis. So we're going to t-bar this to separate our two factors, and each factor gets set equal to 0, placing, at the point where we are on the x-axis. X plus 1 equals 0, and each of these is now solved for x. We would subtract 5 here, so we have x equals -5. Subtract 1 from both sides, and x is equal to -1. Again, leading us to those same two solutions of -5, -1, but just done with a different method. The next method that we are going to apply to the same equation, again, let's write it down one more time so we can keep seeing it. The equation is x squared plus 6x plus 5 equals 0, is the square roots method. So our goal here would be to isolate x squared. So if we did that, we would be minusing 6x, minusing 5 from both sides. We would get x squared equals -6x minus 5, and then we would want to take the square root of both sides, because remember, we're trying to get x squared by itself so we could square root it. Now the left side would become x, but look at this mess that we've made on the right. We actually can't make that any more simple. We've just got a really messy situation here. So if you recall, this equation is not set up to do the square roots method. Okay, we actually can't use it. And we would say it doesn't work because we have an x term. So we cannot solve this using the square roots method since there is an x term. Let's write that down. Okay, cannot solve with this method because there is an x term. Now, when do we like to use the square roots method? Because we do find it very easy. It's like if we had x squared minus 49 equals 0, then we could use it because we would isolate x squared. We would have x squared equals 49, and see how we can take the square root of both those sides. So that is when we like to use the square roots method, but not on this type of problem. So let's keep moving on though. Next method we're going to apply is completing the square, and we just had this on a quiz. So we have the equation x squared plus 6x plus 5 equals 0. When we complete the square, we do not want the equation set equal to 0. We actually like the equation to be set equal to the constant. So the first thing we're going to do is move that constant, number 5, to the right side of the equal sign by subtracting it. We always use opposite operation to move things. So you have x squared plus 6x equals negative 5. Now what we want to do is be able to take the square root of both sides because we're completing the square. But we need a perfect square trinomial on the left side so that we can do that. So the process of completing the square means we take the b value. Okay, the b value is 6. And we divide it by 2. And we get 3. And then we take that number and we square it because we are trying to find a perfect square here. So that is 9. And this number gets added to both sides of the equal sign. Okay, so this number, we're adding it here and here. So that would look like x squared plus 6x plus 9 is equal to negative 5 plus 9. So on the left, this is now a perfect square trinomial, that whole thing. So when we do 1, 2, 3 factor tree, when we factor this, we'll have a perfect square trinomial. The two numbers that multiply to 9 and add to 6 will always be half the b value. 3 and 3. Multiply to positive 9, add to positive 6. So remember, we could have written it as x plus 3 times x plus 3, but we don't like taking in the square root in that form, so we rewrite it as x plus 3 squared. Now what is this equal to? We're going back up here to the top of this equation. On the right side, we have negative 5 plus 9, which is 4. So now that we have two perfect squares on either side of the equal sign, okay, and again, we're trying to get into this x inside the parentheses, we can take the square root of both sides. So the square root of a squared, they cancel out, and I'm going to come up over here. We have just x plus 3. Basically, the parentheses and the squared sign come off. We were left with what was inside the parentheses, and what are we equal to? Now, this is a mistake I saw a lot on the quiz. We are taking make the right side of the equation that number plus or minus in value. So square root of 4 is plus or minus 2. But we are not done. We don't have our solution. X right here, it's not by itself on the left side of the equal sign. So we would have to subtract 3 from both sides to make that happen. Now this gives us two cases right here. We're saying x is equal to a positive 2 minus 3, which is negative 1. It's also equal to negative 2 minus 3, which is negative 5. Where have we seen those numbers before? They are the solutions we're looking for. So x is equal to those same solutions, negative 5, negative 1. But that was using the complete the square method. All right, the last method that we just learned, and we did this lesson yesterday, was the quadratic formula. And the quadratic formula is really awesome. I'm going to write it down here. I would love it for you guys to memorize this formula because it is just so used all the time in algebra. So we say x, remember we're trying to solve for x, is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all being divided by 2 times a. So I told you guys to identify your a, b, and c values. Our equation is x squared plus 6x plus 5 equals 0. Now for this method, you do want the equation set equal to 0. So we are in the right form for that to happen. You should label your a, b, and c values. A is the number in front of x squared, it is 1. B is the number in front of x, it is 6. And c is your constant, 5. Now we just plug those into the formula in the right order using parentheses when we plug in for values. So we have negative and then b. So negative and then parentheses 6 plus or minus big square root. In parentheses we have 6 squared minus 4 times 1 for a, 5 for c. All of this is over 2 times 1. Now, if you're using your Casio, you'll just have to type it all in like this, and one time you would use, right here, you would use the plus sign on your calculator, and then you would go back through and change it to the minus sign, since there really isn't a plus or minus sign on your calculator. But if you're doing it in steps, I would say, we first would want to simplify our negative b value. We would want to get underneath the radical down to one number. And we would want to simplify our denominator down to one number as well. So what would that look like? We have negative and then just 6, so that's going to stay negative 6. And then plus or minus the square root of, what is 6 squared minus 4 times 1 times 5? That'd be 36 minus 20, which is 16, all over 2 times 1, which is 2. And we could keep simplifying it further. What is the square root of 16? Well, that's equal to 4. So we have negative 6 plus or minus 4 over 2. So again, this still creates two problems for us. We would have negative 6 plus 4 divided by 2, which is negative 6 plus 4 is negative 2 divided by 2, which is negative 1, one of the solutions that we knew that we were going to get. We could also do negative 6 minus 4 divided by 2. Negative 6 minus 4 is negative 10 divided by 2 is negative 5. So again, leading us back to those same two solutions. Again, which one's your favorite? I'd be really curious to know. I am very partial to factoring when it works, but I also love the quadratic formula. Okay, I'm a math nerd. Completing the square is not so bad either. Graphing's probably my least favorite, so I'm glad we have graphing calculators, but they're all great and they can all be used. The next part of the lesson, this is the part that's going to really relate to the IXL that you have first for one of your homework assignments, and that is going to be the discriminant, which tells you, when you use the discriminant, maybe which method would be the best method of all of these 5 choices to apply when solving an equation. All right, on to the discriminant. And again, your IXL that you're going to have that goes along with this for the first day will be on identifying just the discriminant. It's not very hard, but you do have to remember what it means. You will be tested on this later. The discriminant, there's a formula for it. And the formula for it is part of the quadratic formula. There's this formula for the discriminant. So we're going to say D for discriminant is equal to B squared minus 4AC. Now, if you remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So really the discriminant is pulled from the quadratic formula. It was the part underneath the radical, and that is a very significant idea because how the discriminant is applied, it's really on what kind of number would we be taking the square root of if we were using the quadratic formula. Okay, and we'll talk about that more here in a minute. But are we taking the square root of something that is a perfect square? Well, when we take the square root of perfect squares, remember the answer doesn't have a radical anymore. It's just a whole number. So that's really easy. Sometimes we have to simplify the radical, but we still get a real number. Sometimes we could take the square root of 0, and that's just it. Or sometimes we take the square root of a negative and we get an imaginary number. So let's see how that's applied. Right down here we have a little code. What information does it provide? Right here. The value of D. When you plug in B squared minus 4AC and you just type that into your calculator, compute the numbers. Again, these B, A, and C values will come from the equation once it's set equal to 0. Now, if the answer that we get when we use B squared minus 4AC for a certain equation is greater than 0, okay, greater than 0, like 1, 2, 3, 4, 5, and is a perfect square. Now, notice we have 2 choices down here that say greater than 0. In red, I say is greater than 0 and is a perfect square. In blue, I have circled where it says is greater than 0 and not a perfect square. So meaning a perfect square like, 25, 36, 81, 121. Those are all numbers that are perfect squares, and there's a ton of them, right? So when the number that we get for the discriminant, b squared minus 4ac, we compute that, and it is greater than 0 and a perfect square, we are going to get 2 real roots. Okay, 2 real roots. That means the parabola would cross the x-axis 2 types, and the type of roots that they will be are real and rational. Okay, meaning no radical in answer anymore. No decimals that go on and on and on and on. Okay, nothing like that. Now, that's because we would be taking the square root of a perfect square, right? That's when it comes back to what was underneath the radical. When you take the square root of a perfect square, there's no more radical in your answer. Now let's show in blue here, if our discriminant is bigger than 0, but it's not a perfect square. Like what if we're taking the square root of 14 or 50, okay, 92, any number bigger than 0 that's not a perfect square, we're still going to get 2 real roots, okay? But our answers won't be rational. They're going to be real and they're going to be irrational, meaning that there will be, okay, yes, a radical in the answer. Meaning there would have been, remember when we get a radical in the answer and we can hit that button, the S to D button, and we get that really, really long decimal? That's what irrational means. Okay, because we would be taking the square root of a number that's not a perfect square. It just doesn't work out right. That's why we love our magic calculators. Now moving on, and we're going to apply this in just a minute so it'll make more sense. If your D value is equal to 0, if you compute B squared minus 4AC and it gives you 0, that means you are only getting one root, which again would mean that your parabola, the vertex, is resting on the x-axis, right? That's what it means when we only get one solution, one root. Root and solution are synonyms here. And those two solutions will be real and rational. Okay, meaning, again, no radical in the answer. Now, what does it mean here if we say if our D value is less than 0? If our discriminant is less than 0, we are going to get two solutions, but they're going to be imaginary solutions. Because if D is less than 0, that means like we could have had like negative 36, negative 52. Doesn't have to even be a perfect square. But what happens when we take the square root of a negative, right? Because I'm thinking of how that B squared minus 4AC, even though we are not taking the square root of it, if we did, what would it make? Taking the square roots of negatives always gives us those imaginary solutions. Okay, so we're going to compute the discriminant on these next four examples, which is what you're going to do in your IXL, and then we're going to talk about how that's going to tell us which method would be the best method to use on a given equation, and we'll practice that on a few different equations. Okay, on these next four examples, like I said, we are going to be computing the discriminant. So the first thing we need to do is label our A, B, and C's because we have to plug those back into the formula. A value is the number in front of x squared, so A is equal to 2, B is equal to 12, and C is equal to negative 13. The discriminant formula, okay, again, D is equal to B squared minus 4AC. So now it's about plugging them in this right order. So in parentheses, we would use 12 and then square it, minus 4 times 2 for A times negative 13 for C. And I wouldn't even bother working it out by order of operations. There's really no need. I would just type it in. What does that equal? Our discriminant would equal 248. Now, what does this mean? What type of roots does this mean? If you try to take the square root of 248, let me even get my calculator on, the square root of 248, okay, we're not taking the square root of 248, but if I did, the square root of 248 would equal 2 square root 62. It's not a perfect square, in other words. So what does this mean for the types of solutions? This means we have two solutions. They are going to be real, but they are going to be irrational because 248 is not a perfect square, okay? So that's something that we need to know as well. Two solutions that are real but irrational. Now let's see what equation number 2 will give us. On equation number 2, the quadratic is negative x squared plus 16x minus 64. Our A value, we have a negative in front of x squared, so that means A is negative 1, B is positive 16, and C is negative 64. So again, using the discriminant formula, okay, discriminant is equal to B squared minus 4AC. So plugging that all in, b is 16, so we're going to use parentheses around it and square it. Minus 4 times a is -1, c is -64. What does all of this equal when you type it into your calculator? It equals, the discriminant is equal to 0. So remember what our code was above. You need to be able to apply that. How many solutions? We have one real solution. And what else do we know about it? That it's also going to be rational. Okay. One real rational solution from this equation. Why do I know that? Because the discriminant is equal to 0. Okay, that's what it's telling us. Let the math talk to you, people. It makes it a lot easier. On number 3, we have the equation -4x squared plus 84 equals 10x. Now notice we are not set equal to 0, we're equal to 10x. And so you can't use the discriminant formula until you are set equal to 0. So the first thing we would need to do is subtract 10x from both sides and then rewrite it in standard form, which is starting with your highest exponent and working down to your constant. So -4x squared minus 10x plus 84 is equal to 0. So what does that make our a, b, and c value? A is -4, b is -10, and our constant is +84. The discriminant is always going to be b squared minus 4ac because that's just what it is. And plug it in. Okay, our d value, our discriminant is equal to b -10 in parentheses squared. If you're not using parentheses, you will get it wrong when you plug it into your calculator. Minus 4 times -4 times 84. Typing all this in just like that with parentheses and everything into our calculator, we get 1444. Now you are going to check, okay, is it a perfect square? Okay, is it? And if you type it in, yes, it is a perfect square. So because what is the square root of 1444? It's 38. So because that came out to be a whole number answer without a decimal or a radical sign, that tells me what kind of solution we're going to get. All right, so that's the discriminant value. Because it is a d value, again, d is greater than 0, and it's a perfect square, that's where I'm getting this from, that info that we talked about above. We're getting two solutions that are real and rational. Okay, that's all the things that we know just because that discriminant was bigger than 0 and was a perfect square. All right, let's finish up with number 4. We have 3x squared plus 24 is equal to 0. A is 3. Now b is the number in front of x. We do not have an x term, so b value here is 0, and our c value is 24. So when we plug this into our discriminant formula, b squared minus 4ac, b is going to be 0 squared minus 4 times a is 3 times c is 24. And what we get is -288. Okay, this represents a d value less than 0. Okay, because it's got a negative sign. Negatives are always less than 0. So that tells us that we have two imaginary roots. Okay, it'd be, if we were using the quadratic formula, it would be the number that we were taking the square root of. So it would result in an imaginary number. Imaginary roots. All right, so the next part we'll talk about how we can use a discriminant to know which method to use to solve our problem. All right, on this next part of your notes, we are talking about choosing the best method to solve a quadratic equation. All right, so we're right here, choosing the best method. Now, our 5 methods are graphing, factoring, square roots, completing the square, and quadratic formula. Now, when can each of these methods be used? When can graphing be used? Can it be used? This is asking like if it can be used sometimes, always, or never. Now, graphing can just be used sometimes, not all the time. Because remember, we don't always cross the x-axis like at a whole number or an integer. And if it's crossing in between 2 points on the graph, we really don't know what those 2 points are. Okay, so when is that sometimes that we like to use graphing? That's when our roots are integers. okay, when it's crossing at an exact value for x, or yeah, not even fractions most of the time. Those aren't great. So when roots are integers. Okay, and we're going to just make a note here. It's not usually practical. Let's put that. Right, just because we get fractions and decimals a lot, and that's so hard to find when you're graphing, especially graphing by hand. So even though graphing is awesome because we can see it, it doesn't always work. Now you're thinking, but whenever you've graphed, you found the solutions very easily. That's because when you practice the graphing method on homework and on the notes that we did, those equations were like specifically made to be graphed. They were giving you ones that could be solved by graphing. When we've done all these other methods, most of those, have like radicals in them or fractions or decimals, and they would not have been fun to graph at all. Okay, so the next method we had was factoring. So that was like 1, 2, 3 factor tree. It's our GCF, it's our difference of squares, and some of you still really hate factoring. Now, keep in mind that can factoring be used all the times or just sometimes? It's another sometimes. It does not always work. Not everything can be factored. Okay, so there are some equations that are prime, not factorable. Now, when do we want to apply the factoring method? Because I think that 1, 2, 3 factor tree is very fast and easy, and when it works, and that's when our roots are rational. Meaning, that was something that our discriminant could tell us. If our d value is greater than 0, okay, we get 2 real and rational solutions if it is a perfect square. That's from your notes above when we talked about the d value being greater than 0 and a perfect square. Factoring, that's when factoring is easy. Okay, now what about square roots method? Square roots method is a sometimes used method. It doesn't work all the time. When can we use this? When there is no b term. No b term, or you could say no x term. That's the b term, right? That's the only time that you can use the square roots method. That's why it's a sometimes. Most of our equations have a b term. Now what about completing the square? Now completing the square actually always works. It's just a 6-step process, so a lot of you really don't like it. But it has a time when it's like better used, even though it always works. The time that it is best used is when there is no x squared coefficient. Okay, no number in front of x squared. And we have an even b value. If we don't have an even b value, then we end up with fractions that we're squaring and adding and subtracting. It can be done, it's just a lot messier. Okay, and then our last, we have quadratic formula, and this is why the quadratic formula is thebomb.com, because it always works as well, and you can use this anytime. Okay, what's nice about the quadratic formula, if you practiced it, we don't care if there's a number in front of x squared. We don't have to divide it out. We just have to get that equation set equal to 0, plug everything in, and it works. So when do we use this? You can use it whenever, but we really use it when all other situations are inefficient or not working. So use when other situations are inefficient. Okay, so on the rest of these notes and examples, we will talk about how to apply the discriminant and use it to pick which method would be the most efficient. So here we go. Okay, so now we have here on the back side of your notes, we have equations A, B, C, and D. And what we're supposed to do here in step 1, it says that we are supposed to find the discriminant of each equation, give the number and type of roots. And then based off that, we're going to go to step 2, which is solve each equation using the methods below. You can only use each method once. So if you have a favorite method, like quadratic formula always works, well, you can't use a quadratic formula on all 4 of these, even though it could be used 4 times. We're going to use each of these 4 equations listed over here, factoring, square roots, completing the square, the quadratic formula. We have to use each one of those methods, match them up with equation A, B, C, and D, based off where it would work best. So Again, first we're finding the discriminant. So on equation A, we have x squared minus 9x plus 21. Our A value is 1, our B value is negative 9, and our C value is 21. We're going to find the discriminant first. So we're going to do in parentheses B is negative 9 squared minus 4 times 1 times 21. And our D value here is going to be negative 3. So if you look back at the front side of your notes, what we talked about before, this D value is less than 0. So that means that we are going to have 2 imaginary roots. And we're going to talk about what that means here in a minute because D was negative 3. Let's go on to equation B and find its discriminant. Our A value is negative 2, our B value is 0 because there is no x term, and our C value is 144. So again, B squared minus 4AC, that's the discriminant. So we have 0 squared minus 4 times negative 2 times 144. Our discriminant for this one is 1,152. Now, again, this is a D value that is greater than 0, but is it a perfect square or not a perfect square? If you take the square root of 1152, you're either going to get a decimal or something with a radical still, depending on which calculator you're using. So this is 2 real, because again, it's positive, but irrational roots. Okay, so we'll come back again to this in a little bit. Let's look at equation C. We have 3x squared minus 22x plus 7. A is 3, B is negative 22, and C is 7. So if we plug into the discriminant, we get B is negative 22 squared minus 4 times 3 times 7. And here our D value is going to be 400. So our D value is greater than 0. If we take the square root of 400, we get 20. There's no decimal, there's no radical, so it is a perfect square. So that means we're going to get 2 real rational roots based off the code from the front side of your notes. That's where I'm getting this information from. Okay, equation D, the last one. Our A value is 1. Our B value is 6. Our C value is negative 15. The discriminant is B squared minus 4AC. So we have 6 squared minus 4 times 1 times negative 15. Plug it all into your calculator if you're following along. But this is all going to make 96. So 96, this is a D value that is greater than 0. And we're going to get 96 is not a perfect square, sorry. So we got 2 real and irrational roots again. Okay. So I'm going to move to a fresh slide, but now if you're looking at the notes, hopefully you printed them out because I had them attached to the student view assignment for here. But underneath, we've got a box for factoring, a box for square roots, a box where it says complete the square, and a box where it says quadratic formula. So based off what these say, which method are we going to use for each? Now, I would start by finding, we have in our first box, it says factoring. Which of these equations would be best for factoring? The code that we did on the bottom of the notes on the front side of this paper, okay, we just talked about. Let me find my paper. It says can be used and when. Now we said factoring works sometimes, but when the roots are rational. So the only one that said rational roots was my one that I did in blue here. Notice it says 2 real rational roots in here. So we are going to use factoring for equation C. You can put that in the box. Okay, so that'll be factoring. When can we use the square roots method? Okay, the square roots method we like to use when the roots can be rational or irrational or even imaginary, but we like to use the square roots method, it says, when there's no b term. So we're looking at equations A, which is x squared minus 9x plus 21. That has a b term. Equation B is negative 2x plus 144. It doesn't have a b term because there's no x term. So we are going to use square roots method on equation B. Again, because it's the only one that doesn't have an x term. It's the only one we can do square roots of both sides. So then we have equation A and equation D left. Now, we said completing the square and quadratic formula always work. So when would we like to use it? It says we like to do completing the square when there's no coefficient in front of x squared and there's an even b term. So notice that on equation A and equation D, they both don't have a number in front of x squared, so it met that criteria for completing the square, but only equation D, I didn't mean to do that, only equation D has an even b value. 6 is even, negative 9 is an odd number. So we're going to say for equation D that we're going to complete the square. Let me write that down because it met the criteria there. So that means we did square roots, complete the square. So that means equation A, we're going to solve with the quadratic formula. It's kind of like your default. When nothing else works, you want to use a quadratic formula. Okay, so if you're printing out the notes, then we're going to do them in the boxes below. I'm going to move to a new slide and just work these out one by one. Okay, we're going to act like I've got the right notes here, but it should say factoring where you're at. And in the little box in the corner, okay, what goes in here is we're going to put equation C, because that one was 3x squared minus 22x plus 7 equals 0. We're going to solve this one by factoring. And again, the reason why we're solving equation C by factoring is because we know that it has two real rational roots, because that's what the discriminant told us. So factoring means we want to count our terms. We have 1, 2, 3. We want to do factor tree, but we can't do that if there's a number in front of x squared. So the first thing you would look for is, does this number come out as a GCF? Does 3 go into 22 and 7? And it does not. So we're going to slide and multiply it to the very last number. It's a slider. So we have x squared minus 22x plus 3 times 7 is 21. It's equal to 0. So now we can do 1, 2, 3 factor tree. Two numbers that multiply to 21 and add to negative 22. Now, when I've told a lot of you this, but if the little trick is if 21 and 22, I'm just looking at the number like their absolute value parts, are like 1 away from each other, then we know that 1 will be one of the factors. And 1 times 21 makes 21. And then I kind of can play around with positive and negative signs to make it fit the adding subtracting puzzle. And to get these two numbers to make a negative 22, we would say negative 1 and negative 21. Now, does a negative 1 and a negative 21 multiply to positive 21? Yes, they do. And negative 1 minus 21 make negative 22. So we have found the two numbers. So now we write it in factored form, which is x minus 1 and then x minus 21 in parentheses, and it's all equal to 0. Now, a lot of kids have asked in the past when we had the quiz on this, well, when do I divide? When it's in factored form like this, before we t-bar it. We're going to divide each of these two numbers by the slider, which was 3. Then we would check, can we simplify either of these? And we can simplify 21 over 3. That's a negative 7. At this point, we would t-bar. And remember, each factor gets set equal to 0. We have x minus 1/3 equals 0, and x minus 7 equals 0. We solve each of these for x. We add 1/3 to both sides, so we get x equals positive 1/3. We'd add 7 to both sides, so x is equal to positive 7. Those are our two solutions for this equation, equation C. X is equal to, in braces, we'd put 1/3 and positive 7. Awesome. Now let's move on to our next box, which was square roots. So let me write that down. This should be what's next on your notes, because we were told to solve each of these methods And in that box, we're going to put equation b for square roots. That equation b is negative 2x squared plus 144 is equal to 0. Now when you use square roots method, we don't want it set equal to 0. We want it set equal to the constant. We want to isolate x squared. So that means we get this 144. We're going to move it to the right side by subtracting it from both sides. So we have negative 2x squared is equal to negative 144. And we're not ready to take the square roots yet because x squared is still not by itself. It's not isolated. So we're dividing both sides by negative 2. Wow, that was cool. Negative 2. So now we have x squared is equal to, let's see, positive 72. Now that x squared right here, and I think some of you need a little refresher on this, x squared is isolated because it's all the way by itself. We're going to solve for x by taking the square root of both sides. What we do to one side, we do to the other. The square root of x squared is, and always will be, x. It's equal to, we're going to put a plus or a minus on the right side. You should always do that. We're trying to get two solutions for x. The square root of 72, this is the same thing as 36 times 2 if you're not using a Casio. So that means that we're at plus or minus the square root of 36. What comes out of there will be 6. 2 stays inside. So plus or minus 6 square root 2. I do love the square roots method. Again, it can only work if there's no b value, so it's not ideal all the time, but it is super quick and fast when it does work. All right, our last two equations. I'm going to do complete the square. This should be your box in your left-hand corner of your notes. Complete the square. And we're going to apply this to equation D. Make sure I save room. We'll do the quadratic formula in the last box. So our equation here was x squared plus 6x minus 15 equals 0. So when we complete this square, hopefully you guys are getting these steps more memorized. We're not equal to 0, we are equal to the constant. So we need to add 15 to both sides. So x squared plus 6x equals 15. And then we want the left side to be able to be factored. So we need to be able to add a third term to the left side. And what we do to one side, we do to the other. So it'll be done to both. This is when we take that b value, which is 6. We'll divide it by 2 to get 3. Square it, and we'll get 9. This number just gets added to both sides. So we're going to be looking like x squared plus 6x plus 9 is equal to 15 plus 9. The left side is now a 1, 2, 3 factor tree situation because we're trying to show it as a perfect square. What multiplies to 9 and adds to 6 will be half the b value, 3 and 3. Multiplies to positive 9, it adds to positive 6. Instead of writing it as x plus 3 times x plus 3 in parentheses, we write it as x plus 3 squared. And then we add 15 plus 9 to get 24. Because both sides are written as perfect squares, we can square root both sides. And this is the only way that we can get the squared off of the parentheses so we can get inside to this x plus 3. So x plus 3 is equal to, put plus or minus automatically on the right side, and the square root of 24. That's not a perfect square. That was the same thing as 4 times 6. The square root of 4 comes out as 2. So we have plus or minus 2 square root 6. Still not finished. X isn't by itself, so we're going to subtract 3, subtract 3. So we're going to say x is equal to, in braces, we would write it as negative 3 plus or minus 2 square root 6 because we're not going to treat these as like terms. We want to keep it as accurate as possible, so we'll leave our answer just like so. All right, almost done. All right, our last equation, we're using the quadratic formula. Okay, this will be in our bottom right-hand corner of your notes. I don't know why I don't have all my slides on here, but I'm making do. And in the box, you should put equation A. And equation A was, let me see, x squared minus 9x plus 21 equals 0. Now, again, it looks so nice and innocent, but if you try to do 1, 2, 3 factor tree, well, it's not gonna work out even though it looks so nice, okay? Again, how do we know that? Because the discriminant for this was -3. That d value of -3 means we're going to get two imaginary numbers, and you cannot do factor tree when you're dealing with imaginaries. Now, you might have just sat here for hours and hours trying to do your factor tree, not realizing it wouldn't work if you had not understood what the discriminant meant. So that's why it's important to know. To use a quadratic formula, we need to be set equal to 0 like we are. We're going to label our A, B, and C's. A is 1, B is -9, and C is 21. Our quadratic formula, if you haven't gotten it down by now, is -b plus or minus the square root of b squared minus 4ac all over 2 times a. So plugging in those values, we have x is equal to negative, and then our b value, -9 in parentheses, plus or minus the square root of -9 squared minus 4 times 1 times 21 all over 2 times 1. We're going to simplify this down. We'll simplify our -b value. We'll simplify down underneath our radical, and we will simplify our denominator. So what is x equal to? So x is equal to our -9 becomes +9. And then we have plus or minus the square root of -9 in parentheses squared minus 4 times 1 times 21. Well, that's going to come out to be -3. And again, that shouldn't be a surprise because b squared minus 4ac is what's underneath the radical, which was the discriminant, which we found out on step 1. So it all kind of goes together. Hopefully you're picking up on that. All over 2 times 1 is 2. So what we have here, we have a little problem. Okay, we can't take the square root of a negative, so we have to take this negative. It's going to get pulled out of the radical as an I. So we're going to rewrite this now as 9 plus or minus I. And the square root of 3 is not, there's nothing we can take out of that. It's just going to stay square root of 3. We put the I in front of the radical, if you remember, and this is all over 2. Now, we can't even simplify this anymore. 9 over 2 does not simplify, neither does 1i over 2. So this is completely simplified. So this right here is our solution. Now, when we see what the solution came out to, it's easy to understand why factoring wouldn't work. We never would have gotten that if we tried to do 1, 2, 3 factor tree. So what you're going to do for your homework when it comes to this lesson, it's kind of going to be over 2 different days. The first day I'm going to give you an iExcel where you're just finding the discriminant. You're using b squared minus 4ac, and then I believe it does also ask at certain questions what type of solutions this would give you. So again, hopefully you took notes and you can refer back to it. The second day for what we're doing, the next day for this lesson is you're going to have a worksheet, and on that worksheet you're going to have to do what we did here on these last 4 problems. You're going to have to solve using certain methods. It's going to tell you for the first, like say 1 and 2, it will tell you to use factoring. 3 and 4, it will tell you on the worksheet you have to use square roots method. On 5 and 6, you'll have to use completing the square. On 7 and 8, I believe it tells you, sorry if that's noisy, to use a quadratic formula. But then on numbers 9, 10, 11, and 12, it's like this last section we just had on the notes on this video, where you have to choose the best method. So again, that might come down to you needing to apply the discriminant and deciding which method would be best used. And again, there's other clues too, but use the clues that are given on the bottom of your notes when on that front side of our notes when it comes to that last 9 through 12. Best of luck. Again, if you are quarantined this week and you are struggling to understand this, or if there's any technology issues, please email me or call me so that I can help you in the best way that you can so you don't get behind. Good luck and have fun. I like math.